Hello ladies and gentlemen, it's modeling time. So we're going to take what we know about trig functions and now we're going to try and create word problems or create functions based on what we know. The first couple are just sort of like, here's some conditions, can you give me an equation? It says, write a sine function with the given conditions. The range is -2 to 2 and the period is 4 pi. Now, I am very visual, so it helps me to see a picture. So what I'm going to do is sketch this and see if maybe it helps me kind of put it all together. It's a sine curve. And so sine curves look like that. The range is 2 to -2, okay. And the period is 4 pi, so this is 4 pi. Now normally the period is 2 pi, so let's talk about what we know. We have an equation that says 2 pi divided by b will give you the period. Well, with a little bit of multiplication, you could multiply both sides by b. And now you have 2 pi equals the period times b, which means if you divide both sides by the period, you can get b. b equals 2 pi divided by the period. Basically, if you flip those two things, then you've got yourself an equation that'll help you find b. So if you want to find the b value in your equation, you do 2 pi divided by whatever the period is. So let's see what that looks like. b is 2 pi divided by the period is 4 pi, which means b is 1/2. Okay, you might think of this as it's half the speed. Instead of doing it in 2 pi, this one does it in 4 pi. So the first thing I know now is that it's going to be the sine of 1/2 x on the inside. That's your b value. And the other thing is this, if the range is -2 to 2, what that's changing is the amplitude. The amplitude is 2, then it's 2 times the sine of 1/2 x. So there's our first function. Let's just say f of x equals. There you go. Let's try another one. The range is 3 to 5 and the period is pi. So the range is 3 to 5. Let's sketch that out. Wait a minute. 3 to 5. 3 to 5. That means the middle is 4. Okay. And if it's a sine function, it's going to look like this still. The period is 1 pi. Okay. So first thing, the fact that the midline is not 0 means there had to have been a vertical shift. So I know there's going to be a +4 on the end because it went up to the middle. The middle of this is 4. The amplitude is 1 because it's going 1 above and below the midline. So I don't need to worry about the amplitude, but I do have a vertical shift, so +4 on the end. The other thing is the period is pi, so let's use what we know here. b will be 2 pi divided by the period, so if the period is pi, then b is 2. So this is the sine of 2x plus 4. The sine of 2x plus 4 will give you this graph. 2x will change the period, and the +4 moves it up so that the midline is now at 4. Let's try one more. The range is 10 to 20, the period is 20, and there's a phase shift to the right. Okay, so the range, let's call this 20 and this 10. That must mean the middle is 15. Okay, so I have a vertical shift to 15. And let's see, what else do I know? There's a phase shift to the right, 5. So this is actually 5 instead of 0. The y-axis is not at 0, it's at 5. And what else? The period is 20. Okay, so this one's got a little bit going on here. First thing, you have a vertical shift of 5, or 15 rather, because the midline is at 15. And then if you're going above and below 15, 5 units, that's the amplitude. The amplitude is 5. The other thing we need is the b value, so we'll do b is 2 pi divided by the 20, which is, or by the period, which is 20. So this will reduce to pi over 10. 2 over 20 is 1/10. So the b value here is pi over 10. So let's put it all together now. Amplitude is 5, so 5 times the sine of, that looks terrible, let's try it again. 5 times the sine of, the b value is pi over 10. And then there's a phase shift to the right. So to move it to the right, it's x, and then you say minus. Minus actually moves it to the right. That seems kind of backwards sometimes, but that's how all functions behave. If you want to move it right 5, you throw an x minus 5 on there. So we have 5 times the sine of pi over 10 times x minus 5. And what else do we need? The vertical shift is 15, so we'll throw a +15 on the end. And that is our function that should look just like that. So there's a lot going on there. But all of those are things that we've done quite a bit of, so you're just kind of piecing it together but going backwards. Now let's see if we can give it a little bit of context. This says a Ferris wheel is 90 feet in the air and has an 85-foot radius. So, okay, let's see. Let's just try to draw some of this. Like, we've got a circle here. That's kind of a circle. That's pretty good. This is 90 feet up and has an 85-foot radius. Okay. It takes 40 seconds to do a full rotation, so that's the period. Oop, forgot. D is 40. And is that it? I think so. Okay, so if you imagine that you are on this gondola and you're going up and down as you move around, you're going up and down. So we talked about this at one point. We did the Ferris wheel problem, and it was like, okay, this is 0, and you're going up. We know that we're going to go above the midline 85 and below the midline 85. So that must be the amplitude. Because if you imagine you're going up and down as you go around, the amplitude is going to be 85. So I know it's 85 times the sine of. And what else? The period is 40, so I'll do b equals 2 pi divided by 40. That means we're talking about pi over 20. So this is pi over 20. And what else do I have? Let's see. So we got pi over 20x, and then we have our vertical shift, so we need to throw a plus 90 in there. So 85 times the sine of pi over 20x plus 90. So you got your vertical shift, you got your amplitude change, you got your period change. Now it says sketch the graph. So let's look at the graph, and I actually did this in Desmos so we can see. Here's my graph. I have 85 times the sine of pi over 20x plus 90. And you look, you're like, yeah, it looks pretty good. Okay, the midline's at 90, goes up. Cool. So if you imagine you're on the Ferris wheel and you start here at the midline, are you starting 90 feet in the air? So if you read the question, it's like, when you get on there, there's a loading platform. That means like down here, there's got to be some kind of loading platform. And if you think, I'm going to get on this Ferris wheel, you're not going to get on the Ferris wheel up here. You're going to get on the Ferris wheel at the bottom. So let's look back at this graph and say, if I want to get on the bottom, well, here's the bottom. What I want this to do is I want that to be my y-axis. So what I'm actually going to do here is I'm going to throw a phase shift in there. And I want to move this thing to the right. So instead of just x, I'm going to say x minus 10. And now, if you look at it, you can see that we are starting at the bottom, which is the whole idea. At 0 seconds, you should be 5 feet in the air. You're not 90 feet in the air when you start. You're 5 feet in the air because you're on a loading platform. So a little bit of a phase shift here makes this make a lot more sense. If you're on the Ferris wheel, you go up, and then you get to the top. Now you're 175 feet in the air, and you go back down. After 40 seconds, you're back at the bottom, which is what we know, 40 seconds to do full rotation. So what I need to do is I need to add the phase shift to this one, because the context of the problem, it wouldn't make sense to get on the Ferris wheel 90 feet in the air. So that's kind of tricky, and the easiest way to do that is to look at the graph. If you look at the actual graph, then you can kind of see like, oh, I kind of need to do a little bit of a phase shift here, and I think what I did was just say I want that to be the bottom, so I'll move it to the right 10. If you wanted to, you could have moved it the other way. So let me just show you. The same thing, if you want to move it left 30, you could say x plus 30. That's the same function, just a different way of writing it. You could also do the same thing with a cosine function if you wanted. But there's lots of ways you could create this function. The important thing is that at 0 seconds, you're 5 feet in the air. All right, let's try our Great Laxey Wheel problem. So this is the Isle of Man. The Isle of Man is where they did a crazy motorcycle race. You should look that up. It's wild stuff. And this is a 170-year-old almost wheel that pumps water. So I'm going to type in the equation, 36.25. I'm going to hide this. 36.25 sine of pi over 12t, sine of pi over 12. I'm going to make it x because otherwise I have to create the function notation. Plus 34.25. 34.25. So here's my wheel, my Laxey wheel. And why is it going under the... If that's the ground, why is it... Oh, it's got to pick up water. So it's going beneath the x-axis because it's going into the water and it's scooping out water. So it's a little bit different because it's going under the x-axis, but that's where it's scooping up the water. So what do we know? How long does it take for the bucket to do 1 revolution? So we just have an equation. We can say it's 2 pi divided by pi over 12, which is 2 pi times 12 over pi, because you copy, change, flip, and that's 24 seconds. So you can see if I look at my graph, 24 seconds. We'll just go from the top to the top. 6 to 30 is 24 seconds. Cool. What's the radius of the wheel? So the radius of the wheel, that'd be the amplitude. The amplitude here is 36.25 feet. Because if you're at the middle and you go above or below the radius, that's going to be your amplitude. And then how high is the center? That's your vertical shift, so 34.25 feet. Okay? I'm just going to use this as my graph here. But when you take a screenshot of this, you should always click all these points. These points are all useful things, so always click them before you ever take a screenshot. When you're doing your project, you have to take some screenshots. So there's a couple things that you need to be able to do for that. One of them is rescale your axes. If you zoom this thing out, like this is trash. Don't turn it in because it's garbage. I can't see anything from it. You need to zoom in, get it close, and then if you need to, hold down the shift key while you're over the y-axis and you can drag. Uh-oh, sticky keys. Oh no. How do I get out of this? There we go. Okay. So if you hold down shift key, you can stretch out like this, or like you do the same thing on the x-axis, you can stretch it out like that. So you can zoom out to get close, or like zoom in to get close, but usually you're going to have to also rescale, because if it looks like that, that's not very good. You can't see anything. I need to be able to tell what I'm looking at, and I don't need to see 37 cycles. Like, oh yeah, there it is. It's like, no, I want to see it go around once. So if I said go around once, you're like, all right, go around once. Midline, all the way up, back to midline. So there's my cycle, and you can tell that the period is going to be how long I need. If you want, you can even make yourself a little equation. Say x equals 24. Like, hey, look, there it is. That's where it gets all the way around. Okay, so you can see these points. Boom. That's one cycle, 0 to 24. Cool. So what you're going to do now is you have a little project on Schoology. You're going to pair up with your table, and you guys need to insert a screenshot, create a function, use Desmos to insert the equation, type up your answers, and submit that on Schoology. That's the last thing that we need to do before our test, and your test will be next week. So go ahead, get it all done, and go ahead and hit that like and subscribe button.